All right, so today I thought we'd open up with a little bit of a review and an exercise that is going to cover basically what we've been doing the last couple of weeks with strings and with file I/O. In particular, what I've got here is a subset of data pulled from Goodreads.com. This is a bunch of book data. So Goodreads has a unique identifier for every single book. The title of the book, so for example, 8127 Anne of Green Gables right here. And then it lists the author, a last name, comma, first name. So there's the last name, and then there's the first name. Then it has the ISBN, which is the unique identifier, International Standard Book Number or something like that. I forget what it is. Then it has a Goodreads rating here, and this is out of 5. I believe that the lowest that you can get is 1, so it's because 1 star up to 5 stars. So this is the average among all Goodreads ratings. There's the original publisher, and then the original publication year, and then there's the date that I read it or that I added it to my list at some point. I've only got a few, let's see, how many do we have here? 42 minus the header there, so I've got 41 records here. And what I want to do is I want to write C code to process this CSV file. Now, we've done this before with one line, with one string, right? We split out my data, like my first name, last name, or whatever. But now we're going to do it with an entire file here, okay? And this is going to be a precursor to the next topic, which is encapsulation. And hopefully it will motivate that topic eventually when we get to it. All right, so my exercise here is going to process that entire CSV file. So obviously I need to open up the file to process it, and remember that there are 3 steps there. Open up the file, process the file, and then finally you close the file. So I'm going to go ahead and open up the file. Remember that fopen returns a file pointer, which I'll simply call F here, okay? And we call fopen for file open. What were the 2 arguments that I provide to fopen to tell it this is the file I want to open it and for what purpose? So the first one is a string that is the relative file path, and if you're in the current working directory, it's good to go /, right? And the file that I want to open is mygoodreads.data.csv. So mygoodreads.data.csv. What is the second argument that we provide to this function? Read or write, right? And so this is an input file, so am I going to read it or am I going to write to it? Read it, okay. Now, remember at the end, I usually like to jump all the way to, not all the way to the end, but I immediately like to close my resource. So for close, F, okay? Then I'll come back up and I will process that file, right? Now, we showed 2 ways of processing a file. Character by character, fgetC to process it character by character. Otherwise, the other one to process it line by line is fgetS for an entire line. Which do we want to use in this case? I want to process each piece of data, and each piece of data is 1 line, so let's go ahead and use forgets, okay? How do I use that? Remember that it returns a pointer to the if it's successful. So I'll call this a line because that's what it is, right? And I will make a call to forgets. Forgets takes 3 arguments. The first argument is the buffer in which you are reading the line. So it's going to read this first line here. Let's go all the way to the beginning. It's going to read that entire first line, and it's going to store it somewhere. And that's, the thing it's going to store it in is in a buffer, right? And I don't have a buffer yet, so let's come up here and create that buffer. Right? Char buffer. And I'll just make it big enough to hold pretty much any line that I'm going to process in this file. This is not the best practice because, of course, you could have a file with very, very long lines, right? Thousands of lines, tens of thousands of lines or something. And in which case you would need a little bit better, more dynamic solution, right? You'd have to go through and find out what is the largest line that I have and then dynamically create a string big enough to hold it. But for all of this data, you know, that looks like a really long line right there. Let's go ahead and see how many characters it is. Looks like VS Code, and it's not telling me, is there, nope, it's not telling me the line numbers or the column numbers. So I'm just going to assume that it's big enough, right? If you really wanted to, you could, of course, put this through a character counter of some sort. Right? But 1,000 is big enough for our purposes for now, okay? The second argument that you give it is a limit, right? It's the size limit, and it's always going to match your buffer size because it's going to read in that line -1, right? so that it puts that in that null terminating character for you. Right? And then finally, the thing that you're reading from here, in this case, it's F. I just called it F. You could go back and call it input file, or something like that, but I'll just go ahead and call it F in this case. Okay? That reads the first line. Okay? And now I want to read every subsequent line. So what we did last time was a while loop. While the thing that that F forgets returns is not equal to null, then that means that you have a line to process. So while the line is not equal to null, right, then I'm going to process each subsequent line. All right, let me go ahead and make that. All right, there we go. So process the current line, right? Current line. ... and then get the next line. Right? And then as long as you're not at the end of the file, then it's not going to return null. But once it gets down to the end of the file, right, all the way down here, then it's going to return null. Okay. All right. So I know that the current line is stored in my buffer right now. All right. Let's go ahead and process that buffer. Right? So the buffer is going to look something like this. Right. There's Harry Potter and the Order of the Phoenix. Right. And it's going to have comma delimited data. When we processed one single CSV record when we were covering string processing, what was the function that we used to do that? You're going to be using it this week in your lab tomorrow. Right? We called those things, each one was a token, right? The first piece of data was a token. The second piece of data, Harry Potter and Order of the Phoenix, that's the second piece of data. That's a second token, third token, fourth token, etc. Each one was delimited by a comma. So if we're going to split it up into all of its tokens, that's called tokenization, and the function to do it is called strtoke. Right? Okay. Now remind me how I work with this thing, though. Right? The first time you call it, you pass in two things. You pass in the string that you want to tokenize, in this case buffer, and then the delimiter that you want to tokenize it on, the commas. Okay? But every time that you call it afterwards, what happens? Right? You want to continue processing the same piece of data. So if you'd started it at the same buffer, right? It would just start tokenizing it again at the same location. You want to make sure that it starts at the next token here, right? The wise man sphere. Right? To do that, every subsequent call, you use null as the first argument instead to continue tokenizing the previous one. Now, if we remember, strtoke will return a pointer to the next token, and we need to capture that. Char star. The first token is the ID, right? So I'll go ahead and call it ID. The second token, char star, well, we now need to look at my data over here, was the title, right? So title is equal to strtoke. Now, when we first covered, and then the third token, let's just go one more, and then we'll talk about this, is going to be the author's last name. So let's call it last name. And while we're here, let's go ahead and get the first name as well. First name. Right. Now, the first time that we talked about strtoke, we did it in the context of a loop, because we didn't know upfront how many tokens we're expecting, right? And so we said, okay, well, if there are 5 tokens, or if there are 6 tokens, or 7 tokens, we'll just go into a while loop while I'm not to the end of the file yet. Remember that strtoke will also return a null when it gets to the end of that string tokenization. So I could do that in a loop if I wanted to. Here's the first token, here's the second token. But I'm actually going to give them all names, right? In this case, ID, title, last name, and first name. Okay? Now, before I go on, tell me about ID. Let's come over here. What do you notice about all these IDs? They seem to all be numbers, right? Is that going to be a number? Is this the biggest number? It looks like the biggest number, right? So is that going to be a number that I can store in an integer if I were to convert this over to an integer, though? Let's find out. So there's millions, hundreds of millions. Looks like it to me, right? So let's go ahead and convert it. If I want the ID instead as an integer, what do I need to do to this ID string version instead? Right? I want to convert that string over to an integer. So this is at the very beginning of the semester. What? A to I, or A to I, of ID string. Right? There. Now I've got it as a proper representation here. But the title, the last name, the first name, those are all strings. No conversion necessary here. Okay? All right. Well, what's next? Let's come back up here. There's an average rating, or ISBN, excuse me, next. ISBNs sometimes have hyphens in them and are sometimes very long, so I don't think that we're going to be able to store that in an integer, but we can grab it. ISBN. All right, there we go. Oh, and then the eternal debate. It's an acronym already. So do we go with lowercase ISBN? Do we go with ISBN like that? Do we go with ISBN? Or do we go with ISBN? Right? So difficult, but that's probably the best compromise. Okay. Okay. All lowercase on that one. What do we have next is the average rating. I'm not going to come back here anymore. I'm just going to cut and paste that and oops. Close the wrong one and bring that over here. All right, so average rating is next. So char average rating is equal to str_toke of null, and again we're tokenizing based on commas here. Except that is average rating. Let me open it back up. That's also a number, right? But now it's a floating point number. Right? So let's convert that now. I'll call this average rating string. And then I want the actual average rating here to be a double. Average rating is equal to, how do I convert that? A to F, right? Because it's alphanumeric to floating point number, right? The rest of them are probably going to be strings, right? So let me grab that. Char star publisher is equal to str_toke. There we go. Original publication year. Oh, that's not a string, is it? Let's come over here and look. 1908, right? Okay. 2004, right? So how would you represent that year? Is it a floating point number? No. Integer. Okay. So char star year, but I'll call it a string so that when I get it, I can then convert it over. Int year is equal to A to I of year str. Okay. And then only one more here. The last one is the date that I read it or that I added it to my personal Goodreads list. Right? Let's come over here and look at that data. So first of all, how would you interpret that data? What date is that? Is that September 25th, 2025, right? And how would you end up representing that? Is it an integer, one integer number? Yeah, it's 3 of them, right? So do you want to split this out further and get the month, the date, and the year? Maybe, right? Maybe just keep it as a string for now because there are better solutions that we'll come up with next or come up with later. And so char star date red, I'll call this, is equal to str_toke. There. Okay. All right. So there is all my data. Then we go ahead and get the next line and process that data. Let's go ahead and make sure that it was actually working here. Let's print all this stuff out. Printf. And I'm not going to print it all out, but I'll go ahead and print out, say, the title by the author's last name, comma, author's first name, and maybe an average, like a year, %D, and then a %F. Those are going to be my year and the average rating. Those are the ones I'm going to be interested in. So bringing all this together, this is going to be the title, the last name, the first name, the year, and the, what else did I say? Average rating? Average rating. There we go. Okay. All right. Let's see if this works. GCC demo. There you go. A dot out. Okay. Wow. Got it on the first try. Almost. Let's come up here to the very top. Is that a real book? Title by author? And released in 0 and has a 0 rating there? No. What did we end up doing here? We ended up processing the first line. That's called a header, right? If you ever look at a table, the table has a header. If you're looking at, say, a spreadsheet, Usually it has a header there as well. Let's go ahead and get rid of that. All right. So I could set this up with an index value or whatever and say, well, if this is my first time running through this while loop, I'll go ahead and ignore it instead. Or what I could do is I could read the first line and then ignore it, right? How could I do that? Reads the first line. Ignore it. Right? How can I ignore it and set myself up for the while loop? Call this again. There we go. Or I could reorder everything. I could put this at the top of the while loop if you wanted to, but then I'm crossing my fingers here because I don't think it would actually work because you get down to null and then you end up processing null, right? So I'm just going to go ahead and ignore the first line there. Let's go ahead and get rid of this. GCC, run this again. There we go. All the way, Romeo and Juliet by Shakespeare is the last one. And then the way up at the top here, Anne of Green Gables is the first one. Is that right? Well, Anne of Green Gables there, the first one. And then Romeo and Juliet is at the bottom. Let's keep a counter, though. How many books were in there? Well, we can cheat and look at it as humans. But what I'm going to do is I'm going to set a counter here. Int num books is equal to 0. Every time I process the current book, I will say num books plus plus. Right? Come down here and printf processed %d book records and the line num books. Right? Now if I come over here and look how many books there are, I see 42 lines, but remember the first one is a header, so I'm expecting 41 books here. Right? GCC, run this, and 41 book records. What if I were to add another one? Would this code still work? Let's go ahead and try it. I'll just add in a dummy variable there. Let's see, artificial condition. That's what I'm reading right now by Martha Wells, Martha. And I'll just make up an ISBN there of 5678. And I don't know, I have no idea, let's just say 4.25, all right? And then publisher, who? And then it was released in, I have no idea, let's just go ahead and say that 2017, let's say. And I'm still in the process of reading it, so let's just say that I'll get it done by the end of the month. What order would I put this? November 30th, 2025. Would I go 11, 30th, 2025? Or would I go 30, 11, 25? Or what would I do? The proper way of doing this is an ISO 8601 formatted string. The proper way of doing this is 2025, 11, 30. Right? There we go. And if it were a different month, say the January, you'd have leading zeros in there as well. That's the only proper way of doing it as a computer scientist because it's lexicographically orderable. The most important number is the year, right? And the second most important number is the month, and then lastly the day. Making sure that all the leading zeros are there. Because now you can use string comparisons to order things in order of temporal order, right? Unfortunately, that's not what they've done here, right? So we're stuck with that, okay? Don't want to go there. Save it. All right, and let's go ahead and see, is it going to successfully get that new book without me changing any of the code whatsoever? It did, right? And why? Well, because I went into a while loop here, and I assumed that all of them were good data. All of it was good data. What if it was not good data? What if I had not included a publisher accidentally? Will it run now? Let's find out. Oh, it did. But what? Probably because, why? In this case, I got rid of the publisher, and that meant that the year was moved up, and therefore, it's wrong, right? What was the year? 2017, right? So what happened was it starts processing this last token for the mistaking it for the year. Sees 11 and thinks that it was published in the year 11 AD, right? So in some things you won't notice them if you're missing a publisher. Some things it'll just have bad data. Other things, for example, if I don't have enough tokens at all, right? That's auto-saved, right? Then I'm going to get a segmentation fault, right? Because now I'm trying to get a whole bunch of tokens that do not exist. Everything after that ID, right? So let me undo that and make sure that it's correct. Yeah, that we're good, right? But I didn't change my code at all, right? In other words, I probably should have done a little bit of error handling up here, right? What happens when you get a null value for the last name? What happens when you get a null value for the publisher, etc., right? Should I go through and count up the number of tokens, or do I just assume that all the data is good? If the data is not good, that's not my problem. That's your problem. You're giving me the data, right? And that's a perfectly acceptable design choice as well, right? Okay. Big problem here, though. What if I wanted to determine what the oldest book that I've read is? Well, let's modify this this code here, right? Let's add some code to keep track of the oldest year. Int oldest year. Python-y. I just did this in Python, and that's why I'm thinking Python here. Python is always lower snake casing, right? What's the oldest year? Let me just go ahead and what's a default value? What's a good default value here? Because what I'm going to do is I'm going to come down here and I'm going to see, there's the year of the book that was released. And so if the year is less than the oldest year so far, then I will go ahead and update the oldest year to be that year. All right? And then at the very end, what I'll do is, in addition to this, I will printf, the oldest book was published in %d, end line, and then oldest year. Okay. GCC this, and now I'm going to have to make a decision here because I can't leave that question mark, right? What would be a sensible starting value here for the oldest year? What if I just made it like really negative there, right? Am I going to find it? It'll say that the oldest book was in 1970. Is 1970 going to be older than that? No. Right? Okay. Something way in the future, right? I could do that. What's the maximum value that an integer can hold? 2 to the 31 minus 1. That'd be a sensible default there. There we go. And then if I find anything less than that, remember that I'm searching for something that's older, something that is less than the oldest year. That'd be good, right? Or I could just say, well, certainly nothing's been published yet in 2026 because we ain't there yet, right? But that one is probably a little bit more future-proof because 10 years from now, or year after year, I'm gonna have to come back and change this code, right? All right, let's see what the oldest book is. Run this. The oldest book was published in -400. That just means 400 BCE, right? So about 2,400 years ago, right? Does that tell me what the oldest book is, though? So what am I going to have to do to keep track of that? I could have cheated and go over to the CSV file and look it up really quick, right? But I don't want to do that. I'm going to have to keep track of the title. Oldest title is equal, and I'll go ahead and leave it like that for now, right? Because if I ever find something that's older, I'm not only going to update the year, but I'm also going to update the oldest title is now equal to title, right? There we go. And now what I can do is I can print out both of those things. The oldest book is %s and was published there, oldest title. Right. Let's see if I can find that out. Sorry. That's definitely wrong. Oh, yeah, I know why it's wrong. So, yeah. There are two issues here, and I forgot about this other issue, but they both illustrate the same thing here. So, artificial condition, that sounds familiar, right? That's the one that I just added, right? Okay. Let's walk through this step by step. I've got the oldest year, and I've got the oldest title. Right? Now what we're going to do is we're going to process each line. Right? Suppose that we fast forward to where the oldest book, -400 book, is being published, and we get its title. We got the title successfully, I can tell you that. Then we set that pointer equal to that pointer. But what happens on the next iteration of this while loop? What? Yeah, the buffer gets cleared out, and it reads the next line. That's why we're getting the very last one here, right? Because that was the last line to be read. So I can't just do this with pointers. I'm going to have to keep track of the actual title. Right? Now, instead of using pointers here, I'm going to have to copy strcpy into the oldest title, the title. Right? That should get the job done. And let's go ahead and see if it does. There we go. The oldest book is The Republic, and published in 400 BCE. Who is it by? Yeah, if you've ever read it, you don't cheat. Do I have enough data here to tell me who it was by? All right, who was it by? Plato. Yeah. Oh, Plato. I don't know. I don't know how you pronounce ancient Greek crap. So, Plato. Indeed. Right. All right. Well, what else would I want to know? What's its average rating? All right. So, if I have any questions about these things, what do I now need to do? I need to keep track of the, let's see, char, oldest, last name 100, right? I need another variable. I need the last name. I need the first name. I need, let's go with oldest first name, too many. And the oldest rating, so double oldest rating, right? Et cetera, et cetera. And anytime I have a question about those books, I have to make another variable, another variable, another variable. Does that sound like a good pattern to follow here? Probably not. Because what if I want the newest book too? Right? What if I want the most popular book, the highest rated book? Right? What if I want the least popular book, though? Right? What if I want all books by Plato or all books by Martha Wells? Right? It seems like keeping all of these things separate is a bad idea. Right? So what I want to do is I want to introduce the next topic, right? Called encapsulation. For us, it's going to be called encapsulation. Right? And let me go ahead and toggle this preview and bring it up. All right, open this in. All right, there we go. All right. In C, that's going to mean what are called structures. Okay. Built-in primitive types like integers, doubles, and characters, they're very limiting. Right. Not everything is a simple number or a simple character. Okay. Real-world entities, say like books, they have multiple pieces of data. They're made up of multiple pieces of data. Right. In programming languages, you can collect and encapsulate these multiple pieces of data together into one logical unit, and again, that's called encapsulation. Right? In C, we do this through structures. However, there is a limitation here. Structures are weak, and this is primarily because C is an older programming language, and these things have evolved over time. And so what we have for encapsulation is actually three things. C doesn't support them all, but there are programming languages that do. Encapsulation in general is the grouping of data together into one logical unit. That's the one that we want. The protection of that data from the outside world, C doesn't have that. And then finally, the grouping of functionality that act on that data. And again, C does not have that easily. Right? So C is not an object-oriented programming language. This is where encapsulation really matured. Object-oriented programming like C++, C#, Java, etc. And so it only supports number one, which is why I call it weak encapsulation. Right? If you go over to a programming language like Java, say next semester, you will have all three of them. Right? Even if you go with a programming language like Python, Python only has 1 and 3, not 2. Right? So you need a full object-oriented programming language to have all three of them. Right? And that's just language design kind of stuff. Why is it that way? I don't know. I didn't design the damn thing. Right? I would have done it differently. Right? All right. So how do I define a structure in order to encapsulate all these things together? What we're going to do is we're going to create a structure that models a book. Right? So let me just come over here and let's create a new file here. Touchbook.h. I'm going to do a header file here, and let's refresh this. There we go. All right. The first thing to do is to define your type. So we use typedef. Have we seen that before? Yep. What types did we define before? Enumerations. This is not an enumeration. This is a structure. So struct for short. We have the same opening and closing curly brackets as we did for an enumerated type. And then at the end, we provide a name for this. And I'm going to call it a book. Because this is kind of a blueprint, right? This is a structure that models one book. Right? We're going to be creating multiple instances, so we're going to have a bunch of books, but this is one of them. So we do not pluralize here. Even if you did pluralize, English is a terrible language for pluralization. Sometimes you add S, sometimes you add ES, sometimes you change the Y to I and add ES. Sometimes it's an entirely different word. Sometimes there are multiple words. People, persons, both of those are acceptable for multiple pluralization of person, right? Okay. Now within this is where we define our structure. I want each one of those pieces of data to be modeled. The first one is an integer that models an ID. Semicolon. That's different than an enumerated type because an enumerated type is a list, and a list uses commas. Cake, comma, ice cream, comma, cookies, whatever else you want, cupcakes, right? Here, it's a declaration of an individual variable, so we use semicolons, just like I would say int x, right? Semicolon at the end of that. What else was in the book? I'm just going to go ahead and grab this and bring it down over here. Right? Book ID. Right? Sometimes you might see people doing this, book ID. There we go. And that's okay too, but it's kind of redundant. Why? I'm already in the book, right? I'm already in the book structure. Why do I need to repeat myself? Remember the DRY principle? Don't repeat yourself. So I'm just going to go ahead with ID here. Title. That's going to be, what type of variable is that? Char star title. Right? The author last name first name. Okay. Char author last name and char star author first name. Something seems icky there. We're going to come back to it later. All right. To do. Is this right? Question mark. Then we've got the ISBN, which is a char star ISBN. Double average rating. Or you could just call it, let's just call it rating, understanding that it's an average. Char star publisher. That's the name of the publisher. Char star, or no, we agreed that a year is a integer. And I'll just call it year here as well. And then finally the date added. Char star date red, I'll call it. And then I'll put another to do here. To do. Is this right? Again, something feels off and icky there. Okay. All right, that's enough. That's all I need to do for a structure. Now what I can do over in my code is I can include book.h. And now I can start creating my own instances of that structure. For example, we've read everything up there. Let's go ahead and put it right here. Book B, right? And end it with a semicolon there. Once I've defined my type def, I can then use it, right? Just like, well, you didn't need to define an integer, but you can declare an integer because it is built into the language. Book is not built into the language. Instead, book is a type that you define, and that's why it's type def. Okay. All right. Well, once I have it, now I need to, actually, use it. Right. So we have what's called a direct component selection operator. In other words, what I want to do is I want to set, say, the ID. Right. I want to set B's ID to that ID up there. So B dot ID is equal to the ID that I just read. This ID right here on line 37. That is the direct component selection operator, but we have a special name for it because that's a mouthful and it's a technical definition. What would you call it? It's a period, but even that's too long. Shorter. What is it? It's a dot. It's the dot operator, right? So we're going to use this as the dot operator. All right. What about the title? B.title is equal to title. Remember, it's a char star. It's a character pointer. Is that how you can copy over a string? Nope. What this is going to end up doing is it's going to end up making a pointer, and we're going to have that same problem that we had before with when I was trying to look for Plato's Republic. It came up with artificial condition by Martha Stewart Wells, and it was all wrong, right? If I'm going to copy over this string, it needs to be a deep copy. Remind me how we do that. strcpy into b.title, title. But have you set up the memory in that book yet? Let's come over here. What is it? It's just a pointer. What is it pointing to at this point? At this point in the program right now, right? B.title. What is that pointing to? Question mark, question mark. Who knows? Dead beef, null, right? What I need to do is I need to set up memory first. So B.title is equal to a call to malloc. So char star malloc. And how big do you want it? Size of char. And how many chars do you want? Well, strlen of title. Title. Is that enough? +1. And proper math. Right. Now I can copy that over. For every single one of these strings, I'm going to have to do the same thing over and over and over again. Is it a good idea to write my own string copy, deep copy function, or take the one that we did in lecture and reuse it? Yes, right? I don't want to do this over and over and over again, right? Because it's going to be a lot of copy pasta, and remember that you've got to change it, right? So last name, right? So last name, and then b.author last name, b.author last name. There we go. Oops. Yeah, this is right. Oh, I shouldn't have changed this one. Sorry. See, I'm already getting myself into trouble here. So author last name, last name. Copy paste. Do it for the first name. Copy paste. Do it for the publisher name, etc., etc., etc. Right? And I'm doing it on every single iteration of my while loop. Okay. It's got to be a better way. You don't copy paste code. You do it once into this thing that we call a unit, or in our nomenclature, what do we call it? A function, right? So let's come back over here and think about a function to do this, right? So I'm going to make this a void function because I'm actually not going to return anything yet. And what I'll call this is init book. Init, short for initialize book, right? And what I'm going to do is I'm going to pass in a book, book B, and all the stuff that makes up the book. Int, ID, char, title, char, author, last name, author, first name, char, author, first name, char, star, ISBN, double rating, char, star, publisher, right? What else am I doing? Year and then date read. So int, year, char, star, date read. Right, there we go. And what I'm going to do is I'm going to hand off this responsibility of creating a book, of initializing a book, and I'm going to let this function do it for me, right? Except this is passed by reference. Are you going to remember our swap demo when we pass in just a regular old integer? Say that this was an integer. Is that function going to be able to make changes to that book? Nope. All right. So if I wanted to make changes to an integer in that swap demo, what do I need to change this into? A pointer. Now let's change this back to a book, right? Because it's just another type, right? Should I put a const in front of it? I'm going to be making changes to your book. I'm going to be setting the title. I'm going to be setting the integer, the ID. I'm going to be setting all this stuff, right? I need to make changes to it, right? And then finally, to do, it initializes the given book with the given values. Right? There, that's all you need. Okay. All right. So at this point, it is a lot of copy paste code, but we can get it done pretty quickly and make sure that it works. I'll do that offline. But I will note here, stylistically, is it a good idea to have a long line there? I don't like it. So what you can generally do is break up long lines, but align things, right? So align that, align the next one, align the next one, align the next one. And the great thing about this is that it starts looking like the the declaration up here, right? Okay. All right, so you can, as long as you align it and be consistent about it, don't just do, I'll do 3 on the first one and 4 on the second and 5 on the last one, right? Align them all, okay? I'm going to save this, and I'm going to copy and paste it because I wonder what A style would do in this case. A style book.h. Let's go ahead and close that and open it back up. Okay, A style agrees with my style, right? Okay. If I had not aligned these things, let's find out if A style fixes it. Get rid of that. A style book. And let's see. Hey, good. So I'm in agreement with A style, and we're all good. Right. No long lines. Now, the disadvantage here is that you've just traded one horizontally long line for one vertically long line. But at least it's a little bit more readable. Okay? All right. So some observations before we continue here. You use the syntax typedef struct. All right? You place the collection inside of curly brackets, delimited by semicolons instead of commas because it's not a list anymore. You're declaring what this thing is, right? And you're declaring each one of those as a variable of that structure. You provide a name at the end, and then you put a semicolon there. Generally, the modern convention is to use upper camel casing, which is why I used uppercase B, right? Because later on, you're going to want to use something like this. Say down here, book B or book, right? Book. And you're going to want to distinguish those two key words, right? Variables are always lower camel cased. The type def, the structure name, that can be upper camel cased, so that you know that what the difference is, and you will get into trouble if you're using a different style there, right? Okay. Generally, you declare a structure inside of a header file of the same or similar name. In our case, it was called book, so I'll go ahead and go with book.h. Again, all lowercase there. Right? Generally, you should document them. We didn't, but you should. Right? Order matters. Right? Composition. One structure might be composed of other structures, in which case you need to declare them first, and the order matters. At this point, I will go back to our design before I get too deep into this thing right here, because I don't want to implement it yet, because we're going to make changes before we do. Right? But let me come back up here and ask, any time that you have more than one piece of data, 2 pieces of data, 3 pieces of data, 4 pieces of data that constitute one logical unit, you should be thinking about composition and structures and encapsulation. Right? Let's go back to our to-dos. Is this right? An author last name and first name. That sounds like 2 pieces of data to me. What should we be doing instead of representing them separately? Another structure. What would you call that structure? A name? Okay. So type def struct opening curly bracket, closing curly bracket, name. Well, lots of things have names, right? I named my car. I haven't named my computer, right? Right? Companies have names, right? An author, however, is different. An author is a what? At least for now, a person, right? Right? Now, when AI gets good enough to start writing, hopefully it doesn't. But there are auto-generated books out there. They're all garbage, but whatever, right? All right, so let's come back up here and let's go ahead and move those names down here. Right? Now, is it a good idea to call this author last name when it's just generally a person? I'm just going to call it last name because a person can also be, I don't know, a director if we were doing films instead, or an actor. Right? They'll have different roles. And so I want this to have usage beyond what I currently have. Right? Now, if you want to, you can put this into a source file called person.h. Right? I'm not going to go that far, though. But I like this because what else could I put in to constitute a person? Age, okay. More specifically, from what could I use to recompute their age? Because their age changes, right? But what doesn't change? Year born, birth date, right? Birth date. Right? To do, is this right? Yes, it's now righter, right? It's better, right? How do I represent a date? Today is, I'm not going to tell you my birthday. Today is November 3rd, 2025. Right? How many things did I just say? November 3rd, 2025. 3 things. What does that seem to you? Like we should make another structure. All right, so let's do it. Type def, struct. And what should I call this? Date, right? Okay. And are these all integers? Int, year, int, month, int, day, right? I'm not going to call it day because it's the day of the month, right? I'm not going to call it date because the entire thing is a date. Right? Alternatively, what else could we have done? ISO 8601. There we go. It's International Standards Body. That's what it looks like. And it's nice and lexicographic. In other words, it's one string. Right? Now, internally, of course, you'd want to convert that string over because what is today plus 5 days? It would be November 8th, right? If you ever want to do any calculations or durations between 2 dates, here's a date, how many days are there between them, right? Then you would need to convert this string into something more calculable, right? But that's another way of representing a date. And in fact, it's the only proper way. Americans get it wrong, Europeans get it wrong, only computer scientists get it right with ISO 8601, right? What's another one? Unix epoch. Yeah, we can go to epoch converter. Right now, that's the time, right? In your computer, most likely, that's the time. It's just one single number. It represents the number of milliseconds since the Unix epoch, which is January 1st, 1970. Right? Is it going up? All right, that's seconds, it looks like. But you can get it more accurate than that, right? And it's just going up and up and up and up, right? You can obviously go back in time. 0 would be January 1st, 1970. And then going negative would be the number of seconds back in time from 1970. That leads to a problem, though, right? What if I were to convert, what was that maximum number again? 2.147 billion that we used. There we go. There we go. So let me go ahead and convert that. There we go. 2038. What's going to happen in 2038? This is the maximum number that you can represent using an integer. What happens when I go over to 8? All right, well, this is working, but generally it's not going to work if it's only 32 bits. Right? This is known as the 2030 problem. Right? And most of you are too young to remember the Y2K problem, right? Where they were using 2 numbers to represent the year. And so in 1999, when it rolled over to 2000, it rolled back to 1900. What's going to happen here is it's going to become something like what? What will it be? It demonstrates it here. There we go. It'll become 1901 again, right? In 2038. That is assuming, of course, that you are using a regular old signed integer, 32-bit integer, to represent your dates in your Unix system. Most dates will use a 64-bit, 64-bit hardware. We're good until I'm not going to be able to read it, but we're good for a few billion years, I think, as long as you upgrade to a 64-bit number, right? And then, of course, several billions of years from now, somebody's going to be sitting in a CS1 lecture talking about, well, they should have foreseen this problem coming too, right? Probably not, no. They'll use something completely different by then, or we won't exist, right? We definitely won't exist. Humans won't, in their current form, won't exist. But the whole point is, how do you represent this? This is the one that we'll go with. However, we still have a problem here that we'll discuss next time of order, right? If I want to use a birth date up here, I can't declare it down here. I have to declare it first, just like any other variable, right? All right, well, I'll see you on Wednesday.